All right, we're gonna get the noise you hear is just Megan Ann stapling stuff. So don't worry about that. Go ahead. Okay, we're going to talk about magneto installation, induction systems, turbochargers, and exhaust systems.
All right.
But when it comes to the magneto installation, I am not going to spend a lot of time. It's not wasting. I'm not going to spend a lot of time on it and write a bunch of notes because we've talked about it. I've showed it over there. But just as a bit of a refresher, because some of you might need it, we shall talk about it. All right. There's some reading that you could do if you wanted to. All right. So the patented three-step process for installing magnetos is what? One. Put the engine at the place where what? Number one is supposed to fire. Where is that typically found? That information? Okay, data plate. The TCDS. Where else might we find it?
M0 manual.
Okay, for Continental, the M0 manual. For Lycoming, I don't remember where. It's a service bulletin or service instruction. It is not in the manual. I usually, for Lycoming, refer to the TCDS or a data plate. All right, put the engine in the place where number one is supposed to fire. Typically, where is that? It is a certain number of degrees before top dead center. Okay, put the engine in the place where number one is supposed to fire. Step two.
The magneto is where it's supposed to fire.
Okay, put the magneto at the place where what?
Number one fire.
When number one cylinder, or in this case the lead, will fire. Step three.
The other.
Put the mag on the engine. Step four.
Yes, to check your work.
Fine tune. All right, should be close. We've got to fine tune a little bit. All right, so let's talk about number one. Putting the engine at the place where number one cylinder is supposed to fire. Put number one cylinder. Just says number one. Cylinder is supposed to fire. All right, many ways to do it. Which brand engine does this have? Lycoming. What is this called?
Start here.
Starter ring gear, support assembly. It's two parts. Therefore, it's an assembly. The big part is called the starter ring gear support, and the little gear on the outside, starter ring gear, because you can actually take the starter ring gear off and change them out. So they're kind of fun to change out. But to change them, you take the old one and you cut it. Take a grinder and you grind a little slit in it until it's almost all the way through. You put it in a vise, and it snaps it the rest of the way. It goes ping, and it snaps out real big, and it comes off. And then you take the new one, you heat it up to, I don't know, about 400 degrees, line it up, and drop it on. And it'll go on both ways. If you mess up and put it on upside down, guess how you get it off?
Same way.
You cut it in half and break it and throw it away and put the new one on. Only had one mechanic do that.
You freeze in the center.
No, it actually goes at room temperature. Yeah, it's surprising. We actually had my shop it's like an old sandwich oven. It worked freaking great. There's a little O right there. That is not by accident. That is by design. And often there is a master bushing on the crankshaft flange. It's different than the rest. And that goes on right there to line it up. But remember, if you're putting this on the engine, well, some of you haven't yet to do this. When you put your Lycoming on the test stand to run it, This can go on 6 different ways.
6. Oh.
So how do you know how to put it on? Well, you're going to put the number 1 cylinder at top dead center, and this has marks. Right there, it's got some timing marks. Top dead center is probably, there it is right there. Top dead center. See how it says top dead center right there? Okay, if I were to turn this around, it would say top dead center somewhere over here. Okay, on the back side. So put the cylinder, number 1, on top dead center, and place this on so that this mark right here, this is top dead center, is about right here on the starter. So this is us standing in front of the engine looking backwards. On the starter, there's a little tiny hole. That little tiny hole lines up. If you don't have the starter on, just look at the back side. It should say top center. It should line up with the backbone of the case, top of the case, right? Okay, once you've got that done, how do you set the engine up to 25 degrees for top dead center? Well, it says it right here. If that's what you go for 20, I just said 25. Look at the type certificate data sheet. Look at the data plate. Let's just say it said 25. Timing is 25 degrees before top dead center. Guess what? One of these numbers says 25. And on the back side of this, one of the numbers say
25.
Line it up at the backbone of the case. Line this up with the hole in the starter, and you are
25.
You're done. You're done. You don't need the flower pot. You don't need anything else. Just be careful that you don't use parallax. Remember what parallax is? That's like when you put your finger out in front of you and you close one eye. Like, you're covering up something, close the other eye, and it moves way over. So you got to make sure that everything is lined up. Follow?
Yeah.
Okay, you don't have to make this harder than it is. So you put it on 25. What else we got here? What if it's not? Hey, this is the, I think, did I show you guys how to use this? I think I did, in building engines, right? The time right. Okay, time right works well. It's hard to set up. We've got the flower pot. Sometimes you don't have good marks or you don't trust the marks that are on the engine. This is a great way to do it. I don't use this particular setup in my shop. I use a digital one that clamps to the propeller. When you start using digital stuff, I don't think these manufacturers ever thought, digital is just beyond their thought process. So, you're working on a 1970 something Cessna, and it tells you that the aileron travel is 15 plus or minus 2 degrees, and now you're using a digital scale. It's like getting in there. It's like, I don't think they ever thought about, well, it's 15 plus or minus 2, so it can be as much as 17, like 17.1. Well, is that good or bad? It's bad, but if you consider the tools that they used to use, it was just a dial like this. It clamped onto the back. I mean, you're lucky if you could read within 3 degrees. I think that's why they said it. So it's just kind of a different world. All right, we already talked about that. Some of the bigger bore Continentals have a timing mark in the back. Mine has this. There was a service bulletin to get rid of this plate right here because people were not paying attention. And so this is that's the generator alternator back there. This gear, it's a sheave, and it's got a keyway in there. The gear only goes on this sheave only goes on the shaft one way, so that you cannot get that mark in the wrong spot. But guess what?
They built a better gas.
The gear that goes into the engine has 20-some teeth, so you only have a 1 in 20 chance of getting it right when you're building that, when you're putting it back together. So the gear could go in anyway, and this shaft sticks out, and somebody goes, oh, it's got to go this way. So you could be off. Well, that's what happened. Is somebody put the assembly together. They mismatched the gears in the engine because there's no timing marks. You got to slide it in a hole. You'll never see it. And then somebody timed the magneto to this back here, and they were off by just enough degrees that it would still run, but cause massive detonation and killed a bunch of people. I guess it happened quite a few times. So came out the service bulletin, said to take this off and throw it away. Can't have it anymore. Well, when I built engines, I would still put it on because it was a service bulletin. You could just make sure that little hash mark right there that's painted red lined up to here when the number 1 cylinder on top dead center. It wasn't real hard. If nothing else, you could assemble it, and if you actually look at these, oftentimes there's many little marks like that around. Just erase them all and put the right one on. My plane has this on, and when I wanted to time my magnetos, I didn't trust it. I used a flower pot, set it all up, verified top dead center, verify the flower pot. So I verified a top dead center, I verified the, whatever, mine's 26, I think. And then it's usable. So again, you don't need to use the flower pot, makes it nice and easy. Some engines, it looks like a drain plug on top of the engine. You pop that off, and there's actually gear in there that has timing marks or counterweights. So there's all different things you can use. But you can always go back to the good old flower pot. It works on pretty much everything. Or you can use the digital version like I have, but I still use this exact same tool right here, the dead stop. Put the dead stop in, rotate the prop around, my little digital on there. When it hits the stop, I hit 0, go around the other way, read it, divide by 2, pull out the stop, go to that one, center it out, top dead center, right? Same thing as the flower pot, it just doesn't scratch the spinner and get stuck. Okay, so we got to put the engine where it's supposed to go. Then we got to put the... Okay. Going back to this, though. One of the mistakes I see people make is they'll go through all the effort of setting it up on top dead center and sometimes get lost in the process of where the engine's supposed to be. Just take a minute and go back and make sure that you're on top dead center of number 1. It's not that hard. Just verify. That's probably the single biggest mistake students make, is they don't verify that they got top dead center of something. Well, just make sure it's top dead center of number 1. Right? Verify that. So verify number 1, and you got to put the magneto where it's supposed to fire. And you either have a Bendix, which has the red tooth in there. Now remember, the red tooth is not going to stay right in the middle when it's in neutral. You guys built this. It's going to be offset a little bit. So you got to remember, you got to put the mag in and turn it a little bit. The other thing that students don't tend to do, I haven't seen anybody in this class do it, is once you get the magneto on and you want to make sure, but before you get a check off or something, or even out in the field before we put the plugs in and fire it up, bring the engine around to top dead center, number 1, about where it should fire, and look in the window. What should I see? A red tooth. What if you don't see a red tooth? You screwed up. It's just an easy way to tell. Number 1, red tooth. Yes, red tooth. Did I talk about these? They make these. Look at aircraft spruce, part number 12-0. So you can buy these wonderful tools. They will screw into this boss right there.
Oh, break it.
And it will reach in there and grab on that little nylon tooth.
Break it off.
Yeah, break it off. And it will break, or it won't break it, it'll just bend it. Because inevitably you're going to bump you put the magneto in, and when you're doing this, you have a lot of torque on it. So it'll crack the tooth. Or you forget, somebody touches the prop, it'll crack the tooth. You hear a little crack, you're like, it's probably fine. And guess what? It's not fine. We actually, in the tool room, and I've never brought him out, I don't have a picture of him, something that is like this, but the whole thing is made out of a rubber, a real soft, clear rubber. And so it's much softer than the gear, so it would hold it reasonably good in place. If you wanted to use those, I think we could try that. I don't have a problem with that, but not the steel ones. Okay, slick LXR hole. What does the left hole mean? L means left. Okay. Left side, left rotation.
Left rotation from the drive end.
It's the rotation when viewed from the drive end. How do I know for sure? It says around the data plate, ROT, which stands for rotation, and it's stamped on a slick. So if it rotates to the left, you use the left hole. What if it's on the left side but it rotates right?
Oh, then it's a
It goes on the left side, but it rotates right. Which hole are you going to use? R. Who cares what side it goes on? Goes in the R hole because it rotates to the right. Where it goes is doesn't care. It doesn't know. Magneto doesn't know if it's a left or a right. It doesn't care either. What's the X for? Slick ignition, the laser ignition system. Okay, remember that the magnetos around here have been abused by students. I got it the other side, I forgot. So that little finger comes around and it hits the pin. And the pin's going to look like that. And you're going to say, Kevin, I can't get the pin out. You have to turn the light off.
Oh.
I can't get the pin out. You know why? Because you bent it over with this thing. So don't bend it over with the finger. So you can see behind there, there's the 3 holes. So you can see if you look real careful that this must be this is the hole that's supposed to be. I think that's the left hole. And if you look, it's not supposed to go into that one, but look how close it is.
Yeah, just slightly off.
Yeah, just slightly off. So if we go back a slide or 2, the L and R holes are not the same distance from the center. So that's what you're trying to do in there. You're trying to match the right hole with the right hole inside. But if you try hard enough, you can make all the holes line up, can't you? That's been done on every magneto around here more than enough times. So make sure that the pin that you are putting in goes straight up and down. If you put the magneto on and you leave the pin in and try and rotate the magneto, you will break the gear. Don't break the gear. All right. Do you know why those are there? See if you remember.
Chinese gears.
Ah, good. I don't know why I say it like that. They were counterfeit. Now, the point to these gears is, what I have a picture up there, is sometimes when you're working with not slicks, because slicks don't have the holes in them, the slots. Remember the slot in the gear? Is it Monday? You guys are tired? The slot in the gear. And so you'll put it on and you'll rotate it and it'll whack it over on this side right here and like, I got to take it off. So you take it off, you move it 1 tooth over, bam, now it whacks over here. So you're thinking, there's not enough play. So what do? You start grinding out the hole bigger and bigger, right? Just take that off and put a slick thing on. Well, the problem is you need a 1/2 a tooth off is where you're at. So how do you get 1/2 a tooth? Take that gear off and rotate it 180 degrees. Because if you actually look at this piece right here, it kind of lines up like this. You can see on this end, it's, well, I didn't do it right. It's in the middle, and this one is on a tooth. So if you can't see this, you just have to believe me. If you take it off and turn it 180 degrees, you look at it, it'll just be 1 tooth different. 1/2 a tooth over, 1/2 a tooth. So if you take 1/2 a tooth off, it'll move in. So, but you won't have to deal with that in the class here because we just don't have that problem. All right. Well, I guess that brings me to induction systems. Let me see. What else do I have on here? Oh yeah. Okay. Let me see. Bendix. Talk about Bendix. What are some cool things here? Slick. Hole. Verify and adjust timing. Use the buzz box to verify and adjust timing. Okay, when you're adjusting timing, never go backwards on the prop to the number. I hope that makes sense. So if you can go backwards, but then always bring it forward to your final number. Never try checking something backwards. Like if you're checking your props, you're like, so you're kind of bumping it. I went too far. I just hit it too far. And you back it this way till the light comes on. Don't do that. You always got to go back further and then into it. Otherwise, you have valve lash in there that's going to throw it off quite a bit. Let's see. Magneto won't work when the buzz box is attached because it's grounded. Is the magneto on or off when it's grounded?
Off.
It's off when it's grounded. It's on when it's... Be surprised how many people don't know that.
At least on
Ignition, is any lead the number 1 lead, or does it have to be a specific lead?
Specifically.
Any lead could be, really. You really could make it. I mean, the magneto doesn't know. It just knows it's going to fire that one right there. It's some tower, right?
Yeah.
Doesn't really know. It's just we've made that number one. And for the most part, leads have been marked as the number one, and so that's the proper way to do it. You look pretty silly if you'd use the number 4 as the number one. I mean, it would work. It's just somebody would eventually go, why does this say top 4? And it's going to 1. And then they'd wonder about you. And you'd probably be called in for a urinalysis test of some sort. But otherwise, the 1 is marked, and then you guys are all doing a great job of knowing what's the next one and what's the next one. What's the firing order of a magneto, 4-cylinder magneto?
1, 3, 2.
Well, that's for the.
That's an engine.
Oh, shit.
Firing order for 4-cylinder engine is 1, 3, 2, 4. What's firing order for a 4-cylinder magneto?
1, 2, 3, 4.
1, 2, 3, 4. All right. All right, let's talk about induction systems. That's where we need to go to. I think. Is there anything else you want to say? Yeah. The other thing about timing, the mistakes you guys are making, take the time to just, I already said it, but take the time to verify that you're actually on the cylinder that you think you're on. Because a couple of you, I've spun the prop around, just spun it, and I've stopped. I said, okay, where are we? And then you stood there and like, oh man, number 2? You know what? You got a 25% chance of being right. But what should you have done? Said, yeah, I don't know, let me find out.
Yeah.
Put your thumb on number 1, pull it around, tell number 1 top compression, go, hey, I'm number 1 now. It's not a guessing game. I'm asking you to figure it out. Show me that you understand the engine. Show me that you know how to get back to number 1 if I mess it up. So, just got to get in there and do it. All right, induction systems. In a lot of ways, except for a lot of ways, everything we're talking about this week is neglected. It's just neglected stuff because, I don't know, it's not sexy, it's not cool or something. People just overlook this, and this is where a lot of the problems find themselves. This is where people die. So it sounds kind of weird, but it's an important subject. So, all right, so induction system. Well, what kind of components we have? Components. Well, first thing you're going to find is a filter. So we have the air inlet. Air inlet. So the inlets are often, well, they're on the engine nacelle. I would say for the number 1 reason of, because that's where the engine is. Number 2 reason is you want to grab some ram air. So what is ram air? Air being forced in from the forward movement of the aircraft or from the prop wash, blasting it in. So prop wash up there, that thing's kind of like its own little supercharger, blasting a little air in. And so is forward air movement, right? Because airplanes move a lot faster than cars. Even a little 150 is going to move around at 40 miles an hour. So that's a joke for the 150 people. What is the 150 flies at about 100, 102, 105, right? About that? Huh?
I don't find 150s.
You don't fly 150s? I don't fit in a 150. All right. So the air inlet is designed to allow ram air from airstream and prop blast to boost manifold pressure. Oh, I read something one time that it was about 5%. Or increases horsepower about 5%. Well, that's a lot for a little 150. That's 5 horsepower. All right, so we have the air inlet. Sometimes the design of the aircraft, there really isn't much of an air inlet. And then the filter's just right up front. Sometimes you have a little bit of a plenum, a little bit of an inlet, then you have the air filter. But regardless, you're going to have that and an air filter. Air filter. What's the air filter for? Yep. removes dirt and larger particles. So I would say I did a poll of myself, and I asked myself, what is the single most common supplemental type certificate that is major alteration to the aircraft across the board? What's the single most common STC? Air filter. It is a major alteration to take off the factory air filter and put on a aftermarket air filter. And almost everybody runs the bracket air filter down here at the bottom. And so those folks are real nice. You buy their filter, they give you a free STC. What does that require if you have an STC? 337. See, I filled out a major alteration repair form. Yeah.
If you do a major alteration, you have to get it approved by IA.
Yes, you do. And then mechanic can put it in, and an IA has to sign it off. Yeah.
Are those oil soaked?
Yes.
Okay.
They are sticky, and I hate touching them. Absolutely hate it. But they're good. So if they ever come and ask, hey, can I help you work? When I do my annuals, people come and help. What can I do? Change the filter for me. So, yeah, fun fact. Let me see. Every 12 months, regardless of hours used, and at the hourly interval of use as stated on service instructions. Only when operating in conditions. Good judgment, squeeze or blot. Somewhere in there it says, do not wash and clean. So one of my first jobs where I worked, brackets have been around for a long time. So being the new guy, you always get the shitty jobs. So what do? Hey, you got to clean this filter. So you go out, you wash it in solvent, and you blow it dry, and then you set it out to dry, and you got to kind of, flick it, get it all. And then they'd have this oil, and then you'd have to pour the oil and get it on there and kind of work it all in. It'd take about half an hour or so. Okay, rule number 1. These are never supposed to be washed and re-oiled. Number 2, it's the cheapest thing in aviation. Mine is pretty large. I think mine's $8. Would it? Nearly $8. So, so I don't know if you're running a shop and you're charging. If I have an airplane and you're charging me to wash my bracket air filter, that'd be in my shop $75 for half an hour for a labor. When I could have bought one for $8, brand new, I'm not going to be happy. So all right, so we pick them up, we throw them out. I run about 200 hours or about every year. It's funny how many times I'll get one in. And you can tell they've been on there for 5 or 6 years. You just touch them and they disintegrate. So you've got a, $60,000, $70,000 plus engine, and you're just too cheap to buy an $8 filter. So don't be afraid to buy filters. Anyway, they come in the kit right there. There's the other type, K&N type. You can see that it's even K&N colored. One of these, K&N cost me a lot of money on one of my cars. So not a fan. You guys run K&Ns?
Yeah.
Not cheap. They're expensive.
Yeah, I had a car where you couldn't go just buy the air filters, and I ride my cars for a long time, so I'll just get the K&N type. And I got a little too much oil in it, and it hit the mass airflow sensor, and that was a $500 part. So yeah.
Do those air filters have a shelf life?
They do. It's quite a ways out there, but you can see that one right there. Expiration. 1 of 09, so it's still good. I don't know how old this. Manufactured 1 of 05 and expired 1 of 09. So you do the math. It's about far.
That's 3,000.
It's 3.
Yeah, so good till
2009.
Long shelf life.
Yeah, when they start to come apart, they really start coming apart. You've seen foam. Just foam with oil on it. It starts coming apart. So, when I'm doing annual inspections, it's one of the things I got to check on all the new planes I'm working on. Do you have your 337? And it's just kind of weird. It's usually the people who don't have them are the ones that cry the loudest. Well, I need 337 bracket. I don't see why it flew in. Yes, it did. I tell you what, my new thing. I tell you what, if you bring me a letter from the FAA saying that you don't need one, I will be happy to sign it off. Here's their number. There's also the paper type. I'm a big fan of bracket. I think they're great. So we got the air filter. We're going to change them and clean them and not ignore them. There are gaskets oftentimes behind these filters. Like you can see the gasket here. What happens if a piece of this gasket breaks off and gets up into the carburetor?
Sucks it up. Engine will go
Yeah.
off.
If you're lucky, it will suck it up and go into the engine. If you're not, a piece will go up, and you know that all of those discharge nozzles, they come out and go up into the airstream. It's going to wrap right around there, disrupt the airflow, and shut off the nozzle, and you're coming down. So that little piece of rubber can kill everybody. And they all have a piece of rubber back there. So that's something I take very seriously and check. That rubber starts. In fact, there was an airworthiness directive on these filters that was happening, and so they had to build them with like a lip in there to keep the gasket from getting sucked in. So you always want to check those gaskets and take very, very serious on these gaskets, because they're not, look, they're just held on by screws here, and there's nothing holding it in that entire section right there. So once they deteriorate, they start coming off.
Would you change the gaskets once you change the filter, or?
No, gaskets and they're really expensive and hard to change. Yeah. There's only a couple places that sell them, and it comes with special glue, and you got to get all the glue off and clean it and glue them on. But so no, I don't. I change the filter every year, every 200 hours on some of these planes, which is every like 2 months. But no, you can order the bracket filter. They're good. But yeah, I change them on condition. All right, so we got the air filter. Air filter. So it removes dirt particles. Let me see. I'm aware of like 3 types. Let me see if there's more I can think of. 3 types. We have the wetted mesh. I would call that like your, what was it? K&N. The dry paper. That's more of the original. I don't even see originals anymore. Everybody's got brackets. Or the foam, which is the bracket. And that one's an STC, which is not to say the wetted mesh isn't, but STC. And I'm not going to write this, but obviously inspect, change, clean as per manufacturer's instructions. That goes with everything. They do not allow you to wash and clean. All right, then we get into the airbox, or alternate air valve.
The wetted mesh is came from
Yeah,
Yeah.
that's what I would say.
How exactly does the foam one like, operate as a filter?
It's a piece of foam. So air has to go through the
Oh,
foam.
it's just a piece of foam. Okay.
Piece of foam with oil in it. It's really sticky oil.
Okay, in my head I was kind of thinking like aerated oil, where it's just like foamy oil on the mesh, not like an actual piece of foam.
It's a piece of foam. Piece of foam with oil. Yeah.
Is it the foam that requires an STC, or is it just bracket as the brand?
Bracket is a brand. I know Bracket is a brand, requires an STC. All right, your next neglected piece of equipment is the airbox. This happens to be an airbox off of a small Continental, similar to what you'd see on a Cessna 150. Fun fact about these is you can buy them real cheap out of spruce. And it says right on there, Home Builder's Airbox. You know what the difference is between a Home Builder's Airbox that looks like that and the one that actually goes on a 150? About $1,000. Yeah. They're insanely expensive. All of these airboxes are insanely expensive. I think the airbox on mine runs somewhere around $8,000.
God damn.
Mm-hmm. So, yeah, you don't want to break them. What happens with these is this bushing right here. It's just a bushing and it wears out. And it would be so much easier if you could just order the one from Spruce. It doesn't cost that much, and throw it on there and you'd be done. But it doesn't work that way. You got a 150.
You need a 150.
You got to fix the bushing. That's about a 4-hour job. So you cut off the ends and you throw away that end, and then there's a flapper valve inside. The flapper valve picture.
Still cheap.
No, I don't. I have to draw the stupid flapper valve. So inside of there, let's see, we have a light colored color. Inside of there is a flapper valve. And when it is in the cold position, let me see, it's going to look something like that. See, that's what this does, that handle right there. And that goes that way, it goes off to your carburetor heat. So the air is going to come through here, hit that, and go up. We'll do 2 just because it's so fun. All right, meanwhile, red. Hot air from around the exhaust muff is coming through here, and there's a hole down at the bottom, and it exits out the bottom. And so that's its normal operation. Then, when you pull the flapper back, yellow? No, must have yellow. It is going to go this way. So the cold air that's coming in doesn't do anything.
Doesn't go off the bottom.
No, I think it does nothing. I don't think it can get to the bottom. Hopefully I'm not wrong on that.
Creeps left.
And the hot air
Yeah.
comes this way and up. Draws hot air in off of the muff. Yeah, I guess it would have to open up that box down here. So maybe it goes out the bottom here, right? Otherwise that hole would still be open. It can't be open. It could be, so there we go, out the bottom.
So does that hot air not really filter?
Nope, completely unfiltered.
It's gone through the engine already.
Nope, not going through the engine. It's unfiltered hot air.
From the exhaust.
So we're not from the exhaust, from around the exhaust.
Oh.
So if we talk about the exhaust, see, exhaust is going to come in right here, travel through and go out that hole. But what is all this right here?
Hot air.
It's just really hot up in there. And you don't see that part because it's got this over it. So it's got this shroud over it. So you can see right there, oops, that this over here, you can't see it, but over, there's always got to be an inlet. So you'll have air coming in as an inlet, goes across those little pegs, sometimes there's pegs, sometimes they're not, then it comes out of here and goes either to the carburetor heat, which is the other side on this airplane, or off here to the cabin. So what happens if you get a little crack in this? You go sleepy.
Start
You're
getting
gonna
a little
take a
light
good
here.
nap.
All right. Light combing, Continental tends to do a little bit, they're more aggressive with their carb heat and heaters like this. Light combing is not as aggressive. They do a little more like that. It's just like a little can around the exhaust right there. So I guess I tell you that part to say it's really important that if you think you have carb ice, you use your carb heat before you reduce the power. Because once you reduce the power, these pipes are going to start cooling down. So I think I told a story about that recently where somebody's like, yeah, we had carb ice. You pulled the carb heat? Yes, we did. And then it wasn't until later I said, when did you pull it exactly? Oh, we've been on final with the power off for quite a while. Like, well, that pipe was probably pretty cold by then. So all right. So
Where's the inlet usually located for going into the can?
like on small Cessnas, it's right up front with the opening for the air to come in, the engine. There's like a little scoop right there. Just trying to think where mine is. I don't remember where the scoop is. I think it's the same place. Oh, fan, I don't remember. It'll come to me. Airbox. All right, so what does that airbox do? Well, it provides heat. That one provides heat that I showed you. Fuel-injected engines don't have carburetor heats because they don't have carburetors, so they don't need heat. But one type of icing you can get is impact ice. So where ice comes and smacks in front of it blocks off the air filter. Well, there's no carb heat in the world that's going to help you with that one because it is way before the carb heat. With a carbureted engine, you can pull on the carburetor heat and it gives you an alternate path. You won't melt the ice, but you still get air. Follow?
Mm-hmm.
Okay. With a fuel-injected engine, they don't have carburetor heat, but they still have to have an alternate means of getting air. So they have an alternate air door. So somewhere there will be a door inside, usually inside the cowling where it's warm, it won't ice over, it's magnetically held closed. And if the suction gets too great on the intake system, pops that door open and allows air to come in. And there's a little spring on there that allow it to close back up when you shut the engine off. Yeah. So your air box provides heat or alternate air. You always got to have an alternate air source. So carb heat is pilot controlled. What's the carb heat for?
Heating up the carburetor.
To melt the ice that gets in the carburetor. So pilots that fly carbureted engines, I was taught, and I still do it most of the time, that, all right, I'm downwind and you look at the numbers and you're about to reduce power and start your descent. First thing is carb heat, especially if you fly a Cessna 150. Those things make ice like crazy because the carburetor hangs so far down. Like Cummings, it's bolted to the sump, which is hot. Continentals, it's down low. Mine's way down low on my 182. So they are prone to ice. So first thing is, no matter what the temperature is, reach over, carb heat on. Then reduce the power, and then you're going to go into your descent.
Is that carb heat just off-road?
No, it's you can do partial. A lot of people with 182s recommend partial carb heat. Some planes do have a carburetor air temperature gauge, and what you get is a green line right in the middle. So too hot for icing, too cold for icing. So I was flying around Saturday. I think it was up over Yosemite at about 12.5. Look over, and it's right in it's dead center in the yellow. I mean, just the whole flight. I don't care. I've flown all the way to Boston with it in the middle. It didn't ice up. It just doesn't seem to do that at higher power settings. So I don't worry about it. If I started to lose airspeed, I started to lose manifold pressure, what does that tell me? I'm getting some ice. So what do? Just reach over and pull it out. I'm going to run rough for a second. Some people with 182 say you should apply a little bit of carb heat. It helps give a better mixture to the cylinders. I don't know about that. I don't really want hot air going into the engine, so I don't. Maybe I'm wrong. Let's see. So carb heat is pilot controlled, and I know it. So alternate air is usually automatic. And by usually, I mean I don't know anyone that's not. Usually,
Mine is not.
yours not? It's usually then. Is usually automatic and operated by intake suction, which should make sense. If you block the filter up front, what's going to happen to your suction in your manifold?
It's gonna go somewhere.
Oh, man, that engine's thirsty. It wants some air. It's going to start pulling on everything it can. And if it wasn't for that alternate air door, it would start caving in tubing and stuff if it could to get some air. But it doesn't. There's a little spring-loaded door. Pops open and it's happy. And then that draws in warmer air from inside the cowling, where it's not snowing and it's not icy in there usually. All right, so we're working our way through the intake system. First we have the air inlet, then we got an air filter, then we got an air box or alternate air door, and then we're going to work our way to, by the way, I'm pretty much thinking mostly of a non-turbo system here. Then we're going to get to our carburetor, fuel injection, servo, we'll say servo, or throttle body. Air is going to go through that. We've already talked about all those things, so we can just move on to E. Now at that point, it becomes the intake manifold. And I'll call it intake manifold. Okay. intake manifold, or we just call it intake pipes. Let's see. I have so many notes here. We can probably abbreviate some of them. Let's see. Well, it's obvious. These are the tubes that carry. The fuel air mixture, or if it's fuel injected, just the air, because there's no fuel at this point. Fuel doesn't get injected till the cylinders. So it's fuel air mix 2 cylinders. They may be exposed pipes, may be exposed. Like Continental. Continental pretty much used all exposed pipes. You can see them all the way. See them from the carburetor. They're going to go like the O200s. They're going to go up this way, or the bigger bore engines start low in the back, come up, go around the engine, go all the way forward, and kind of break off into each cylinder with the tube up front. I got a picture of that. But it's time for a break, so you can do a break.
Take note.